Alright, grade 11s. Today we're going to learn about z-scores. Okay? The z-score is the number of standard deviations away a piece of data is from the mean. The formula to calculate the z-score is z is equal to x minus mu over sigma. So x is whatever data value you're given. So if you want to see how your grade compared to the grades of the students in the class, you would take your grade, which would be x, minus the mean, which would be mu, the average mark, divided by the standard deviation. A positive z-score indicates the value is above the mean. A negative z-score indicates the value is less than the mean. Z-scores equal to 0 illustrate the value is equal to the mean. In many ways, a z-score is a good way to compare things, and we'll talk a little bit more about that later. Okay? So example. The Canadian Olympic track team has participants in the 4x100 meter relay with 100 meter times ranging from 9.92 seconds to 10.40 seconds. If the participants have a mean time of 10.16 seconds and a standard deviation is 0.16 seconds, find the number of standard deviations away from the mean that the track team is satisfied with. So in other words, what we need to do is we need to find the z-score for the low time and for the high time, just using that formula that we used above, or talked about above. So that formula is z equals x minus mu over sigma. Okay? So, what's x? Well, the first x is 9.92. So z equals 9.92. The mean is 10.16 seconds. And the standard deviation is 0.16. So all we have to do is figure that out. So we're going to get negative 0.24 all over 0.16. And if we divide those two together, we get negative 1.5. So z-score is negative 1.5. It's negative, so that tells you that it's below the mean. And 1.5 just means it's 1.5 standard deviations away from the mean. So let's take a look at the other time. The other time is (10.40) minus 10.16 all over 0.16. So that's 0.24 divided by 0.16. The z-score is 1.5, so it's positive 1.5. So the track team is satisfied with times that are 1.5 standard deviations above and below the mean. Okay? So the z-scores are found by taking your data value minus the mean and divided by the standard deviation. So let's standardize two sets of scores. So what I was saying is that the z-score is a very good way of comparing things. So consider this example. Say we're comparing Natasha's math mark with her friend, I don't know, maybe her friend Vivian. And her friend Vivian goes to a different school, somewhere different city. Maybe she lives in, I don't know, Brandon. Now the thing is that without being able to know how difficult the class is, how can you really compare their marks? Well, the only way to compare their marks is to compare each of their marks to their peers and then have that measure to compare to one another. And that's what the z-score is it's a measure of how well you're doing compared to your peers. Someone might have 90% in something, but if everyone else has 95%, then 90% is pretty useless. Likewise, if a class is really tough and all the marks are in maybe the 50s and the 60s, and if you have a 60, for example, then that mark isn't so bad. So that's why it's a good idea to standardize two sets of scores. In other words, it's a way of leveling the playing field and being able to compare two sets of data. So in Germany, grade point average is on a 6-point scale. In the United States, it's on a 4-point scale. Petra Latt has a 5.1 GPA in Germany. Her peers in law school have the following GPAs, blah, 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 blah. Amanda Spalding has a 3.3 GPA in law school at Ball State University in Indiana. Her peers have the following GPAs, blah, 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 blah. Question is, which law student is doing better compared to their peers? So what we need to do is we need to type these into a calculator and figure it out. Okay? So what I'm going to do is I'm going to go ahead and punch these into the calculator. Now the only thing is I don't know if this is going to work nicely with what I want to do. Because what I want to do is I want to go like this. Okay, that's beautiful actually. Good. Maybe I can take this and move this over a wee bit. Would that be good? I don't know how much it's going to let me move it, to be honest. Well, that's doable. So what I'm going to do is I have to go, and you see I've got some list stuff up. So I'm going to go second mem, and I'm going to go option 4, clear all my lists. There you go, my lists are cleared. Now I'm going to go stat, enter, and I'm going to enter in Petra's peers law marks. So that's 4.7, 5.5, 5.0, 4.9, 5.4, 5.8, 4.1, 4.5. Oopsies, I gotta fix up something here. I've got 4.9, 5.4, 5.8, 4.1. I can't read apparently. Okay, we're gonna delete. 4.1, 4.5, and 4.3. Okay, so what we have to do is we have to figure out that's 2, 4, 6, 8, 9. Now that does not include Petra's mark of 5.1. So if it doesn't include Petra's mark of 5.1, then we need to actually enter that on the 10th line. So that's 5.1. And now we go back to the home screen and we go stat, calc, one variable stats, enter, and we're interested in the mean and standard deviation. Now the mean is 4.93. So that's the mean. Now what's the standard deviation? The standard deviation is 0.52 if we round to 2 decimal places. So standard deviation is 0.52. Now we want to do the same thing for Amanda. So we go back here, second mem, clear all lists, option 4, bam. Now we go to our list, so stat, enter, and we start entering. So we'll enter Amanda's first, so that's 3.3, 4, 3.6, 3.8, 2.5, 2.9, 3.1, 3.3, oopsies, 3.3, 3.4, and 2.3. Okay, now second, quit, stat, calc, one variable stats, enter, mean is 3.22, and standard deviation is 0.51. So very similar standard deviation. So now we can find Petra and Amanda's z-scores, and then we can figure out who's doing better compared to their peers. So we'll start off with Petra. Petra's 5.1. So we'll start off with Petra. So z is going to equal x minus mu over sigma, and z is going to be 5.1 minus 0.493, all divided by, oopsies, that's not 0.493, it is 4.93, all divided by 0.52. So that's going to be 0.17 divided by 0.52, which is going to be 0.33. So it's a positive z-score, so Petra's above the average, and the z-score is 0.33. Now let's do Amanda. Amanda is z equals x minus mu over sigma. So Amanda's GPA is 3.3 minus 3.22 divided by 0.51. So we get 0.08 divided by 0.51. Amanda's z-score is 0.16. Whose z-score is higher? It's Petra's. So therefore, Petra is doing better compared to her peers. Okay? Perfect. Alright, so that's it. Petra is doing better compared to her peers. Alright? Good. Alright, so that's that example done. Now, next example. Natasha asks Mr. Hutton her score on the last math test. Mr. Hutton tells her the class average was 72%, standard deviation was 8%, and Natasha's mark had a z-score of 3.25. How well did Natasha do on the test? So we're going to look at the formula here. Z equals x minus mu over sigma. Now, the z-score is 3.25. The x-score is x. The mean? Well, the mean is 72%. Standard deviation? Well, that's 8. So now all we're going to do is a little bit of algebraic manipulation. So we're going to multiply 8 by 3.25. That's going to give us 26 is equal to x minus 72. Bring 72 over. 26 plus 72. X is equal to 98%. So Natasha's mark is 98%. Okay? So again, we're using that formula, z equals x minus mu over sigma. We're filling in the information that we're given, and we're solving for x, Natasha's mark. Okay? Alright. Another example. There's a mean of 597 first-year students in education at the University of Manitoba with a standard deviation of 23. Find the z-score for the 2006-2007 academic year, which had 630 first-year students. Okay? So, to do this, what we're going to do is we're going to use the formula again. Z equals x minus mu over sigma. Alright, so now that's going to give us x is 630. Mu is 597. Standard deviation is 23. So that's 33 over 23, which is going to be 1.44. So that's part A. So far, we've done this question exactly like we've done all the other questions. Part B is where we start to do things a wee bit differently. Part B asks us, find the probability of the school having an enrollment greater than that in 2007-2008. So in other words, here's our normal distribution. Here's the mean right here. And 1.44 would probably be somewhere around here. What we want to do is we want to find this probability right here. How do we do it? Well, we're going to go to our graphing calculator, go to the home screen, clear it, and what we're going to do is we're going to use something called normal CDF. How do we use it? Well, what we're going to do is we're going to go to distributions. So that's second, vars. And you're going to get this menu right here. And I want you to pick option 2, which is normal CDF. What we want to do is we want to see the probability going from 1.44 onwards. So we want to see the probability between a z-score of 1.44, which is our lower bound. So your lower bound goes here, and your upper bound goes there. Now we're not trying to find the probability between 1.4 standard deviations and some other number of standard deviations. We're trying to make this as high as possible. Now remember that standard deviations basically go up to about 3 or 4, but just to make things nice and straightforward, let's put in like 10 or something here. If we put 10 or something here, and then press enter, we see that the probability is going to be 0.07, or approximately 7%. So I can go back here, and I can say that we went normal, CDF, 1.44 to 10, and this was 0.07, or 7%. So that's the probability of there being greater than 630 first-year students. And because we're talking about greater than, we're going to the right of that. If we are talking about less than, then we'd be going to the left of that number. Okay? And remember that the entire area under the curve adds up to 1. So if it was less than, we'd expect it would be about 93%, or 0.93. Okay? Because that's the opposite as greater than. Okay. So now we have normal CDF as a tool in our tool chest to solve these questions. So going on to the next question, Dell produces high-quality LCD monitors and has a mean of 5 dead pixels in the monitors produced so far this year, with a standard deviation of 2.1 pixels. Dell will replace a monitor if it has more than 10 dead pixels. So far this year, they've produced 40,000 LCD displays. How many do they expect to replace? So here's the deal. We want to find the probability that there's greater than 10 dead pixels. So in other words, that's what we want to find. But first we need to find the z-score for it. So the z-score is for 10, it's going to be 10 minus the mean. What's the mean? Well, the mean is 5. All divided by the standard deviation, which is 2.1 pixels. So we get 5 divided by 2.1, which is going to give us 2.38. Gives us a z-score of 2.38. So what we want to do is we want to find the probability that z is bigger than 2.38. So to do that, again, we're going to go to the normal CDF. So that's going to be the normal CDF. And now our lower bound, again, because it's greater than 2.38, is going to be 2.38. And then we can just go up to 10. So going back to our thing here, we can go second, entry. Actually, never mind. Well, we might as well just go second, distribution, normal CDF, and then type in 2.38 to 10. 2.38 to 10. And we get a probability of about. Now we're going to have to write this out to several decimal places if we're because we can't write this down to 1% because that would be. So let's write this out to 0.0087. 0.0087, which is not even 1%. It would be 1% rounded. So how many do they expect to replace? Well, it's going to be that times 47,000, or 40,000 rather. So if we took this number here, and if the great thing about the graphing calculator is you can just go times, and it'll take your answer and automatically multiply it by 40,000, and we're going to get 346.25. So 0.0087 times 40,000 is going to be about 346.25. We'll say it's 346 monitors. So Dell should expect to replace about 346 monitors of the 40,000 that they produce. Okay? Alright, last example. A pizza delivery company has a mean delivery time of 27 minutes. Statistics show that 10% of the time their delivery time is under 20 minutes. Find the standard deviation. So what we see here is for x equals 20, we know the mean's 27. We know that the probability is 10%. So in other words, what we want to know is we want to figure out what z-score has a probability of 10%. So the probability that x is less than some value here is equal to 10%. What we want to do is we want to find the value of the question mark. So how to do that is we use a different function on the graphing calculator that we haven't quite used yet. What we're going to do is we're going to go back to that second, distributions, and we're going to use inverse norm, which is the third one. And the inverse norm is when we basically plug in the probability, and it's going to give us a z-score. So we know the probability is 0.1, and we get negative 1.28. So going back here, I see that z is going to be negative 1.28. And we got that from taking the inverse norm of 0.1. That was negative 1.28. Now that we have z is equal to negative 1.28, we can plug it into the z-score formula. Z is equal to x minus mu over sigma. So z is going to be, our x value is 20, that's given. Our mean is 27, that's given. And we don't know the standard deviation. But we do know that z-score is negative 1.28. So now here's what I know. I know that negative 1.28 is equal to negative 7 divided by sigma. If I do a little bit of rearranging, sigma is going to be negative 7 divided by negative 1.28. So what the heck is sigma going to be? Well, the standard deviation is going to be 7 divided by 1.28. The two negatives make a positive. So that's going to be 5.47 minutes. That's the standard deviation. Okay? So your homework is on pages 264 to 266, and it's numbers 1 to 20. And I'm just going to double check that that's consistent with what we have here. Yes, it is. So there's your homework, and you will have 2 periods to work on this. Okay?